Alright, we're live. Uh, let's do the usual check. So there's plenty delay in between, but hey. So yesterday we fixed our bugs. We had a few bugs that were caused uh, by the lack of concurrency and not properly handling the resources that were being used by the GPU. We fixed those, and now we've got a rendering that's going on, and we don't crash until we actually uh, quit the quit the program, and that is because we are we are allocating some memory from uh, resource loader, and we're not freeing it, and that is because we haven't actually abstracted out the resource loader. Okay, so today I'm going to start the redesign. So I wanna redesign the whole thing, and we'll figure out how that will go. So there's plenty I can close now. I'm not gonna look at those codes anymore. We have our own little abstraction here. We're going to redesign it. Okay, let's see what our interfaces are. What, what is wrong? Why can I not close this? That's weird. That's definitely weird. So that's a bug right there. We cannot close this. Anyways, get rid of all this. Let's close all of it so we can actually reason about it. So one thing that actually comes to mind is that let's do all that. Alright. So one thing that actually comes to mind is that when you actually uh, pass something to a command here, you're actually kind of binding it to that uh, to the to the lifetime of that command. Not only the lifetime of that command is going to use that resource, and that resource's lifetime is bound to that use. So we need to somehow uh, provide a method design that would handle that. For example, a simple example of that would be like, actually that is in submit. This submit would cause that. And before that submit, it is on command itself. And let's see our destructor here. Our destructor waits on this fence only. It should also wait on the semaphore, I believe. I believe this command cannot be destroyed until actually this is done. I believe that is the case. Let's see the implementation. Okay, that is just nice. Did it actually crash? No? Huh? What the hell happened there? What the hell just happened there? I will do a quick search of that. Maybe not, because it's being copied here. So wait some for it's gonna wait, blah blah, but it's going to copy this. and copy it via the allocate. It is not fine to do allocate here. Allocate comes with the cost that the rest of your stack is dynamic from here on. So you're paying a cost for every stack access you're doing. Anyways, so yeah, so that is safe. That is safe there. That fence is enough. Oh, actually, we're even waiting on that fence, so yeah, it's completely fine. But we're not passing this offense, are we? I guess we are. So that is one thing that I'm thinking about that kind of like directly directly link these together, like the use case here and the object itself. So I don't want the object to be destroyed in any ways, like before it's actually done being processed by the GPU. And the other thing that I have in mind is that I want it to be directly destroyed, if needed, directly destroyed after the use by the GPU is over. So I want immediate termination of lifetime, like as soon as possible. I don't want to do garbage collection. Like this is kind of like garbage collection. And yeah, this is not like garbage collection, but we are waiting here. So I don't want to check if I should wait or not every time I want to destruct something or add something. So I have this wait for everything that would actually I don't need these weights here. These are extra weights. But on my removes I'm requiring a wait even if this object is not actually being used by the GPU. So I kind of want something that would like signal me when the GPU is done working with the resource, and then I would be able to actually uh, I would be able to actually get rid of the resource anytime I want it. However, that design might come with an overhead. Rate semaphore there, and the signal semaphore is here. I'm wondering, I'm actually waiting on the command right now. Let's just remove the extra things first. We have extra weights on ads. So let's find every add function and remove these weights. Doesn't need to wait on there. Same here. We're not removing resources, so it is safe not to wait. Same as there. That's a remove call. This is an add call. Removing that. Initialize with need one. Get swap chain. Those are getters. That is the init. It needs one. Add render target doesn't need it. Neither does it have. I just removed it, I guess. Add pipeline. This doesn't need it. And that's it. Okay, so On one on let's come here. Let's come here. There is a wait in here. Wait for idle. Where's my queue structure? Correct command and that is my okay. That's command queue. That is my queue structure. Okay, and I am calling this. That is it. That is waiting on the queue and seeing if it is actually idle. Let's check that. So it is using the queue fence. And who is setting the queue fence? So what I'm trying to do is get some kind of signaling from the queue per element. So I would have a render target like a render target and then a semaphore next to it. That would tell me if it is actually being used or not. I guess that would be the ultimate goal. However, it could cause me some trouble. Let's read more code into this. Let's see where this let's see this add queue and let's figure out where that fence is actually initialized. I'm looking for a fence. Okay, that's the fence that is add fence. Okay, so the problem with the code at the moment is that this is a single fence here. That's just a single fence. So if I were to actually do this, I would have a command and then I would add fences to that command. And those fences would be like if I were to I would if I were to like bind some resources to that command or do whatever with my resources to that command, I would add to fence that correlates to the set resource to the command, and then the command would notify that the resource has been released by the GPU and I am safe to actually do whatever I want with it. That is really what I have in mind. The other way would be that I would uh, limit my resources to commands. So it would be unsafe to like use resources from other commands on this command. That's another way of doing this. So if I abstract the code like that, that would be better, I guess. So I would just need to like focus on the fact that if this resource was used, I don't know. That's actually one way of doing it. Okay, I guess I have to design it in my mind now. I believe I do. I believe I have to design. Okay, I think I have a design. So what I want to do is that I would set like something like, let's get to our command queue. So in my abstraction, I'm going to use a single queue per command. So let's see where this queue is actually used. Everywhere that this queue is used. So it is used in swap chain. Submit queue graphics. I guess I can't do that. I can't have a single queue per all the commands I have. Anyways, what I want to do is that my command here, it does this. Where's my submit? Every time I submit something, the command is waiting on this. Let's look at this. So it is waiting on the fence here. So I could add a counter here that would count up every time that I would acquire it, and then that would generate an ID. So I would provide that ID to the resource, and the resource would understand like if the ID matches the current ID, the resource is being used. If not, the resource has been released, and the resource can actually be deleted. So I believe that's what I'm going to do because we have a wait here. So we kind of have we're kind of doing the kind of pipelining. So like each frame is a segment of the pipeline, and each time that we move forward in the pipeline, we understand that we can figure out that actually uh, the resource has been released by the previous step because we're in the next step now. So I guess that is the design I'm going for, but that design has a single problem, and that is that our command here that we're waiting on is actually, we have several commands and the queue we're using is single. We should actually wait on queue rather than the command. So the queue could not be idle, but every time that it is idle, I want to figure out. So maybe there should be some kind of notification system here that the queue would like signal us every time that a submit has been finished. So I don't know. I have no idea where we're using this queue. So we have a present queue here. Our swap chain is gonna use that to present. So the queue kind of look like a shared storage that is shared between multiple threads. So here is the submit command. The submit uses it, and the swap chain. Okay. Few problems are coming into my mind. This is gonna be kind of a weird session. I'm mostly going to think about the stuff rather than talking. I will try to think out loud, but I don't think I'm gonna be much successful at that. So what I'm thinking about at the moment, so I want some way of notifying my objects really with low overhead that either either it is being used by the GPU or not. That's all I want to do. So each object cannot be automatically uh, updated. We don't have any threads that is running and checking if the object is actually valid or not. So whenever we try to use an object, we should query whether the object is uh, done being used by the queue or not. That is what we should try to do. So some part of the we should have two variables that go out of sync. Like it's supposed to be A, but it's not. It's B. So there's a what would you say, mismatch there, and that mismatch signifies that my resource isn't available for me to do whatever I want with it, like to release it. So since my resources are not being updated, so the part that should be updated is the queue. So that is what I'm trying to do. So we have this queue here, and it does have a fence. So I'm trying to use that fence as some way of actually realizing that we have the the queue has gone actually, what would you say? The queue has gone idle. So let's see the submit command. Where's our submit function here? Let's find our submit function and read that. So this is our submit function here. What it does is end command, then it would have a queue submit descriptor, and then it would submit it into the queue. And I believe that would cause the queue. Let's see this. Let's see what we're doing with this signal semaphores. Here, that is signal semaphore count, and that is the signal. Alright, that is wait semaphore. Where is the signal semaphore? That is signal semaphore. PQDXQ semaphore fence. So we will be signaled by this. Maybe that is enough for us. Like maybe this is actually enough. So what this is doing is that it's saying that you have to signal me if the queue is done. Okay, I'm happy with that. So the design can actually work. However, I need participation from graphics command. So what I mean by that is that there would be a single ID here, a uint64 so that I can make sure that we're not going to wrap around. Alright, and then what I would do is each time that I would you can't actually do that. I don't know, because actually my object can be in use by several stuff. That's the problem, yeah. Like my object can be in use by two commands at the same time. So if the first command comes and adds an ID into it, and the second command comes and update that ID, I will lose all the information regarding the uh, first command. One way of fixing that would be to limit my resources to the command. I don't want to limit my resources to command. How do we actually fix this? That is kind of mind-boggling to me at the moment. We're kind of moving forward in design, but that is still vague. Like, I know what I want to do. So let's implement some stuff here. So here is, after these weights, is where I would update my. So we said that we have two. Let's say we have a resource here. Okay, let's call it our struct IYP pipeline. Okay, let's say we have a pipeline here. It holds whatever you want and whatever we might need. Then I would have a token in it, a uint64 synchronization token. Right? And this would be an optional maybe, but I don't want to pay for the optional. Anyways, we would have a synchronization token. Then I would set the synchronization token. Maybe the type would change later, I don't know. I'm just brainstorming here. So the synchronization token may have changed, I don't know. I have no idea. So what I want to do is to have another token in my queue here, in my graphics queue. Let's say we have another synchronization token. Okay. And what I would want to do, let's copy paste that. What I would want to do is I would check my synchronization token with the synchronization token in the command, and if those synchronization tokens are not equal, I would say that this pipeline here is not being used by this graphics command. Okay, so that is what I have in mind. But and we also know that this synchronization token is not going to be updated by itself. This is only going to be updated if I use this pipeline somewhere, and then that would be updated. So to actually make these two out of sync, I need to update this one. So when should I update this one? And to update this one, I should use, let's see. Let's see. To update that one, where's my graphics command here? To update that one, I should update it here. This is the point that I realized that whatever I had submitted by this command is actually processed. So the resources that was used in that command are not free. That is something that we can do there. And still that wouldn't fix all the synchronization we need. There's another part of the synchronization, and that is the fact that so actually yeah, we would need some kind of so for example this command is going to have some resource that is going to be modified. Like let's say this command would write into one texture or a render target for what we care here, and those resources should be stored in this command, because if I use those resources in other command, then the two command could be written it at the same time. That is why we have these fences and semaphores here. These are uh, to actually fix the race conditions on the swap chain render target. That is why we have these. I believe that is the case why we have those. Let's see where this is actually used. I'm kind of vague on that. It is also used for present. That is to signal the present, I guess. That is only used to signal the present functionality. And I guess this is going to be on the swap chain itself. Alright. So I'm also thinking that our only synchronization process is going to be synchronization of CPU and GPU. We're not going to be working on any CPU, like any two threads on the same CPU would need any kind of synchronization. No, we're not going to do that. So our objects are not thread safe. They are single threaded objects. So let's get back to the idea. That is my synchronization token. I would need to set something to this at this point right here. Here I would need to modify that. But how would I modify that? And to what should I modify it? Because we could have, virtually we could have multiple commands. So the idea is that we have, I don't know. So I guess it is actually safe to use like two pipelines in two commands at the same time. How would that go? I don't know. Anyways, so the idea is however many graphics commands I would need a synchronization token regarding that command. So in other sense, this would be an area of multiple command, an area of size the number of commands. And then my command would have a synchronization token. And I would compare my synchronization token to the set command synchronization token. That is not a nice design. Firstly, we do not have this number here. We don't know how many commands we have. Secondly, I would need to actually hold to the command to actually figure out whether I am out of date or not, and I would need to do a whole complete iteration here. So how do we fix that? How do we properly fix that? Huh. Okay, alright. Let's see. Okay, I guess I have it done. Let's say we have another integer here, and that is the number of use cases this has. So that is synchronization token use. Let's change the names. This would be number of in use. The other thing that comes to mind is whether it's actually hard to check if we are. This helps me to actually figure out whether I am in use or not. I am still going to need to wait on that. And how am I going to handle the waiting process? I don't know. Number of using commands. We have a bunch of commands that are useless. Okay, and then number of finished uses. So let's say we're being used this many times, and then this many have actually done using us. So I'm going to add these together, and this should be less than a number in there. Is that correct? That is still not correct. No, this wouldn't work. This still would not work. I don't know, maybe we don't actually need to do this, but from my standpoint, we should actually know who are using us. So either we should our lifetime, it should depend on our users. So we shouldn't go out of lifetime before our users finish using us. So we kind of need some solution for that. Maybe this is not the solution here. So from what I see, the DXQ here is actually providing us with the solution. So you can signal multiple people. So every time that I would use a resource with this, I would call that. Let's see the other versions of this QSubmit. Let's see how the Vulkan version does this. Do we have signaling here as well? Let me check that. Where's our fence here? Do we have a fence? I guess we don't use the fence on D3011. Let's check that. Okay. So I guess D3011 doesn't actually provide D3011 doesn't actually provide any kind of asynchronous process between GPU and CPU. Is that it? I don't know. Let's see our full conversion. Here's our fence again. Let's see where it's used. Q submit, and then we pass the fence there. Let's see that Q submitting. There is no. Let's check this. Vulkan Q submit. So I'm actually thinking about the hell next. Come on, mate. I agree. Get all my data. Share it with everyone. Steal it. VK fence, there's only one fence. So what I was actually thinking about was to what I was thinking about was to do the same kind of design with the Vulkan, where I would provide multiple fences, and each resource would have a fence, and then I would figure out whether it is done or not. Seemingly, that is not what's happening here. Then who does actually signal our semaphore rate semaphores? Who does actually signal our signal semaphores? That is weird. What the hell? UK semaphore, signal semaphore count. Let's see who uses these. Okay, submit info. Alright. That actually supports this. Alright, alright, alright. Okay, I guess we are actually, we have whatever we needed, don't we? This submit. We have whatever we need in submit here. Okay. I think I know what I'm doing here. Wait samples right there. So actually the Forge engine is providing us with the proper interface here. And that is this. PB semaphores, signal semaphores. And that is why this is being used here. This actually belongs to the render target. This belongs to the swap chain there. Okay, okay. I like that, I guess. I think I like this. Redesign has been there all this time, and I wasn't seeing it. So let's say I'm gonna bind render targets, bind pipelines, whatever. I would add my semaphore to the list of semaphores that is being used by this command. And then on submit, sorry about that, on submit, it would signal my semaphores. But is there actually a way provided by Forge on waiting on semaphores? Wait, wait queue idle, no. Wait for fences. I wanna wait on semaphores. How do we wait for semaphores? Guess we don't. There's no difference between fences and semaphores? Are you kidding me? Are you kidding me? Why would you have two types for that? I guess in Vulkan version that might be different. Semaphore. Okay, and Vulkan version is different. So if I was able to actually wait on a semaphore, if I was able to wait on the semaphore, I would simply wait on that. That would be easy to me. But seemingly you cannot wait on semaphore. Why is that? Let's check semaphore here. Let's see all the interface that is provided for semaphore. That is add semaphore, remove semaphore, and acquire next image. That also takes semaphore. Submit queue also takes semaphores. Signal semaphore. Queue present. It also takes some semaphores, and that's it. What is the use of semaphore for me as a user? That is the question here to be asked. I should ask them. Let's ask them right now. Okay, I just asked them. Let's see. Let's see if anyone answers. Please signal semaphores. It is it is actually it should be quite normal to be able to actually wait on a signal semaphore. Let's see how the wait is happening here. Queue submit, there's the wait semaphores. Let's see how we wait on these wait semaphores. Simply wait. The XQ wait. Expense. Let's see the Vulkan version and see how Vulkan actually waits on this. So my wait semaphore blah blah, wait count plus plus. What is happening? P wait semaphore is copied here. DVK semaphore is copied there. Then I guess we are waiting on this. Wait semaphores. It's kind of interesting how the designs are very similar. Designs are really similar in the submit. Let's search for wait. Also, let's remove that. Let's see if we can actually. There's an there's a Vulkan interface that would do the wait. This is actually really insightful, at least to me. I don't know how you feel as a viewer, but to me it is pretty insightful. Getting some actual insight to how the Forge engine is working with the Vulkan or D3D. So on it looks like on the VK wait for fences. Here reset fences. Let's see if there is VK wait for semaphore. We know that the D we just learned that VK semaphore. We just learned that the semaphore on D3D12 implementation is simply only a it is simply only a fence, so we can wait on fences, so we can there we have it. Huh, I do not have this. I think that should be present. I think we should have that interface. So from what I understand from this code is that we can actually have wait semaphore, the wait semaphore interface. The D3D11 would do nothing. The Vulkan version would just wait under semaphore and then probably just reset the semaphore, and I think it wouldn't need to reset the semaphore. It would just wait on that. Wait on the semaphore. And then waiting for maybe you should reset the semaphore. So that way, what I would do, my design would turn into this. Each object would have its own semaphore. Then at submit, I would add using the command here. Let's find out. Okay, here. So whatever we use here, I'm going to pass that uh, semaphore in, and with that semaphore in, I'm going to have a vector of semaphores here, and those semaphores will be later on passed to passed to the queue in the submit process. And then I would wait on those. I would wait on those on everything that I would want to do. This is kind of this is that semaphore right there is the semaphore for swap chain. So it is literally just the same exact uh, process being badly implemented. So I guess that abstraction would help a lot. And all my resource management would be fine. I will try to uh, I can actually implement my own wait right away and see if it actually works. I think I'm pretty capable of implementing that. But it would definitely be nice to like get the interface from the Forge. That would be nice. Okay. I guess it's enough for today. We figured out a lot really. We figured out the design. There are still parts of the design that are missing. If I were to like add some force to each object that can be uh, allocated from the renderer, for example a sampler, this sampler handle wouldn't be enough to have the sampler pointer as the sampler handler, because then I would miss all the information about the semaphore I have with the sampler. So I would need to kinda uh, figure that out. Figure out what to return as sampler handle. I know one thing that I could do is to provide the pointer to my sampler objects, which I will be maintaining from then on to the user. However, the user wouldn't be able to do some of the trickeries we have done with our handles here. Like we are doing this kind of thing here, and not that kind of thing. But let's see. We actually some of the places we are using, yeah. For example, this. I wouldn't be able to do this. Sorry, I got disconnected. So I just realized I was talking to myself for like 10 or 20 seconds. So what I was saying is that I'm also thinking about making these interfaces, these add and remove interfaces thread safe, because then it would provide me with the ability to actually like have a thread just looping around to be able to remove the resource from the GPU as soon as possible. Sorry for the optics. Resource streaming in and out. So I would have a thread that would just be watching for the GPU to be done using the resource, and then it would immediately remove the resource. So yeah, those things would be good to have, but I don't think we are anywhere close to actually achieving that. So I guess we're going to have to implement uh, single threaded versions for now, and then we will try to figure out ways to actually provide that kind of interface, that kind of thread safe interface for removing resources. Okay, thank you for watching. I guess that's all for today. Tomorrow I will implement my own based on 7.4s. Then I will start by implementing each of the objects, because each object is going to go with a semaphore from then on. Okay, thank you for watching. See you next time.